I'm going to talk you through how to calculate reliability using Excel. So we're going to look at correlation and we're going to look at percentage difference between your hand notation and your computerized system. So first of all, you'll need to find your sports code package. So sports code package. It should look something like this. So you've got your instances in the timeline, and then if you click on the matrix, this summarizes your results. So here are your results. You can click on any one of these and it should bring up the video related to that instance. So to get this into Excel, we need to go to this button here, Export, and you need to just click on Excel. So if we click on Excel there, it'll ask us to save it where we want to. So I'll save it on the desktop for the purpose of this. Let's save there. We'll use XLS because that's what we want. MP4 is a video, so we don't really want that. So use XLS. And that's down there. We can see that. So we need to close this down now. And then if we open this up, yes, it will look something like this. Yours might not be as extensive as this, but it's the whole concept. So your code buttons are on the left hand side and your label buttons are at the top. So that's the way it should be. So I've formatted a spreadsheet already, so I'm going to go into that one. So we go to this. So we've got Observer 1 and you've imported or input your data from the hand notation system into the bottom here. So we've got, we might call this computerized, and then this one could be hand notation. So we've got computerized versus hand notation. We have our computerized and hand notation results. We can start to look at the mean, which is the average, standard deviation, and the correlation. So we need to add an extra, let's say 4 rows into here so we can have a look at those totals. So we go 1, hold shift down, the arrow, an arrow down, an arrow down. Right click, and then it's insert. So we have our cells now. So here we're going to have the average or the mean. Here we'll have the standard deviation, and we'll save the correlation for underneath the hand notation. So to work out the average, it's just a simple equation of pressing equals, start to type average, AV, and there it is. So we just click on that once, and then within these brackets we need to select the area that we want to know the average for. So we select those and then just press return, and that's our average. And we can make these bold. So for the standard deviation, it's the same process. So it's equals ST, there we go, STDEV. Click on that once. It's asking us to select the range. So we're selecting the range that we want to find the standard deviation. Make sure you don't include the average because that could be problematic. So we press return now, and there's our average and standard deviation. So once we have the average and standard deviation, we can make these to 2 decimal points. So we select those, right click, format cells, go to number, and there we go, 2 decimal places. It looks a bit more believable now. So we drag that down, We can drag those across all the way to the end. Okay, and these are our totals. If we select those, we can make them bold, so they stand out and we know what they mean. So now we have to do the same for observer, the second observation or hand notation. So we'll insert a couple of rows here, right click, insert. So we need average, standard deviation. We'll make these rows, we'll make these 3 bold. So it's equals average. It's asking us for the range, so we'll do the same as we did with the computerized notation results. And we can also drag those across. So equals STDV, click on it once, and then asking us for the range, and return. So we can change them to 2 decimal places. And drag those across. Okay, you'll drag them all the way over to the end. So we need the correlation now. So correlation. So we need to do the same as we did for average and standard deviation. So we go equals, and it comes up. So all we have to type in is COR, and it does it for us. So we click on that once, and we want to look at the correlation between hand notation and computerized. You can do it vice versa, it's fine. So we highlight that, and there's a comma in between. It's telling us here. So if we press the comma, and we want to look at hand notation. So we're looking at the correlation between computerized and hand notation. If there's a strong correlation, then there's less disagreements between the two. We know it's a strong correlation by this key here. So if it's 0.7 to 1, that's strong. 0.3 to 0.69, moderate. 0 to 0.29 is weak. Okay. So we know that this one is strong. So we can change the cells on this one. So we'll change them to 2 decimal places. And we can drag those across. And instantly you'll see that this one here, that one, and that one. This is example data, so it might not be the case that corner kicks and covering depth are unreliable between the hand notation and computerized, but for this example that's what the results have shown up. So we've got corner kick and covering depth. So we need to look into more detail of why that is. We need to look at the errors, so whether it's an operational error, an observational error, or a definitional error. So whether the operational definition needs to be clearer and more concise. So what you can do for this, you can also visualize the correlation and look for the R² value. So put the line of best fit, which is this one, and see how strong that best fit between the two results are, and that's what the R² value is showing us. So for this, you need to put this set of results against this set of results, so they're next to each other like that. So say I want to look at the variable corner kicks. So I'll look at corner kicks. So I'll highlight that, copy it, so Command and C. I'm going to open another sheet. I'm going to press Command and V. I'll do it the other way now, just in case you don't want to use shortcuts. So right click, copy, right click, paste. So this is, if we right click here, insert, this is our computer, this is our hand. So we're looking at the differences between those. Okay, so it's going to be exactly like that. So we need these names down here. So it's looking more like a table now. So we need to plot this on a scatter graph. So we're looking at the total, the mean, standard deviation, and correlation. We can do that also. So if we just highlight those now, so we can highlight those, insert, and go to scatter graph. That's how easy it is. Click on that and it plots it against one another. So we can see that it's not similar to the strong correlation of 1v1 defense, which is in a positive direction, whereas this is a bit sporadic and all over the place. It's quite positive here, but then we've got this outlier up here. So if we can select that to get our line of best fit. So we add a trend line. So it's looking like it is positive, but then we get our R² value and look how low that is. The closer to 1, the stronger the relationship. Okay, so we'll make that font a bit bigger so you can see it. So once we've got that. So for yours, you're going to have a title on this axis and this axis. So if we click on that, we're going to format this now. So that isn't just hand corner kick, it's just corner kick. So we're looking at the action variable corner kick and we're testing its reliability against the hand versus the computer system. So if we go to, click on here, go on chart design and quick layout. So we want a title and axes titles. So we click on there. It's also give us a legend, which we don't need. So we click on that and press backspace. We might have to add our tread line in again and our R². So this is your y-axis. To check this out, to check which one's which, if we click on this, right click and select data. If we click on this section here, so we need to know what the X is. That's the X, so it's computer. So this is the X across the bottom, which is a horizontal axis. And then we've got the vertical here, which is the Y. So we know that's computer, so we can call it computer. So all I did for that is right click, select data, and click on, so we know the Y value here, which is the top, that should be hand. So there's the Y, and that's going to be hand. And this is the X, so it's going to be computer. If I press OK. So that one's hand notation. And that one's computerized notation. So our graph is coming together nicely. So it's showing that there's a negative, well, there's a positive correlation, but then the line of best fit is not very strong at all. So we can look at, now if we get the totals, so if we put in total here as our title, we press equals sum, because we want to find the sum of these. Sorry, did that wrong. open the brackets, so it's sum, open the brackets, select your area and press return, and that's a total of 3 and 7. So you can see there's a big difference, and we'll find now we're going to do the Hughes and Frank's 2004, 2008 and 2015 percentage difference. So this has to be below 10% for it to be a reliable variable, which it probably won't be because there are small numbers here. So if we select there, so we need the average. No, let's not do the average actually. We'll do the Hughes and Frank's calculation. So we're going to merge those now because we're measuring both of those variables against one another. So we'll merge those. So we need to do, first of all, we need to find the difference, don't we? So if we go equals sum, that minus that equals, so it's minus 4. So now we've got the difference, we need to find the average of both of those. So the average now, so we go equals average like we did before, but instead of doing this range here, we're selecting these two because we want to find the average of those two. So it's 5. So then it's 4 divided by 5 times by 100, and that's what we'll work. That's what's going to give us our percentage now. So equals sum, open the brackets, so it's that divided by that is 0.8. So to make that a percentage, click on it and click this percentage here. So it's 80%, which in terms of things it needs to be below 10%, so we know there's an error there. So within this sheet we know there's an error for this player and this player. The other two are the same. So we need to look into those and see what kind of errors they are to rectify those errors. So whether it's your observational, operational, or your definitional. So whether it's a problem with the definition. Okay, so that's our error. So percentage difference between the hand and computerized notation. And that's what you should do.